Hi folks, welcome to the video. This is a review of the AS Maths mock from 2023. The intention for me is to go through every single question on this paper and write up a full worked solution. Before you watch me go through those questions though, I would strongly recommend that you guys work through the questions. Anything that you couldn't do in the exam, try and work through it with your notes at your own pace. Because often it plays out very differently when you're outside of that sort of timed environment. There will be a copy of the paper provided and a copy of some short solutions so you can see if you've done it right. Once you're happy with it, or if you get stuck somewhere, you can come back to this video and have a little look at my solution. What I'm also going to do per question is have a look at the mark schemes so you can see the breakdown of what you get in terms of method marks versus accuracy. Hopefully that all sounds good. I'll see you at some point in the video. Okay, so here's question 1. We're kicking off with some surds, and we are being asked to simplify that expression with 3 different elements to it. We have got this rationalizing the denominator thing in the middle, and we've got 2 other expressions on the side. So what I'm going to plan to do is to evaluate all of these 3 things separately, starting with the 5 root 48. What I'm thinking with this one is 48 can be broken down into 16 and 3 multiplied together. So I'm looking to use the rule of surds. This is the same as root 16 times root 3. Good thing about 16 is it is equivalent to 4. So this first expression works out as 20 root 3. I think that's as good as I'm going to get there. I'm actually going to do this in a bit of a funny order. I'm going to go for this expression, the 2 root 3 cubed, next, just because I think it looks a little bit easier than term in the middle. Written it down wrong straight away. 2 root 3 cubed. So that is the same as 2 root 3 times another 2 root 3, another 3. And I'm going to multiply all of these numerical terms here, 2 times 2 times 2, to give me 8. And now I'm going to think about the root 3 parts I've got going on. I know that 2 surds, when multiplied, effectively cancel out and give the term inside the bracket. So this is going to work out as 8 times 3 times root 3. And I can evaluate this as 24 root 3. So I've got 2 bits worked out. I know that this is 20 root 3. And I know that this is 24 root 3. It's nice when that sort of thing happens, right? You can think like, oh yeah, I'd be able to combine those 2 terms. The term in green looks a little bit more interesting, and I think I'm going to have a bit more to do here. So it's 2 plus 5 root 5 on the top of the fraction. I've said that wrong straight away, haven't I? 5 root 3, and I'm dividing by 5 plus root 3. So I'm going to need to do a technique called rationalizing the denominator for this, which basically means get rid of the surds on the bottom of the fraction. To do this, I'm going to multiply by a variation of what's on the bottom. Specifically, I'm going to multiply the top and bottom by 5, take away 3 root 3. So this is going to be like expanding double brackets on the top and on the bottom of this fraction. So on my fraction bar, not very neat. Let's use a straight line to do that. Much better. Fantastic. Look at that. Wonderful. So it's my expectation that simplifying the denominator here will fully cancel it. I'm not going to use my calculator. Oh, my wife's saying hello to me. That's really nice. I'll go see her. I'll come back. Okay, where were we? We were going to rationalize the denominator and we were going to expand out these double brackets. So let's deal with the top of the fraction first. Let's multiply these two terms. 2 times 5 is going to be 10. Now let's do these ones. 2 times minus 3 root 3. 2 times 3 is 6. 6 root 3. Now let's multiply these terms. 5 root 3 times 5 is 25. 3. Finally, this last term. 5 times 3 is 15, minus 15. And then I'm going to have root 3 times root 3, 3. Bit more to tidy up there, but I'm going to do that in a second. And let's have a look at the bottom of the fraction. Hoping with the bottom that the surds will cancel, of course. Let's start once again with my foiling process. 5 times 5 is 25. This is going to give me minus 15 root 3. Next term is going to give me positive 15 root 3. And the final term, I'm once again going to times the numbers, then times the surds. 3 times 3 is 9, it's minus. And root 3 times root 3 is 3. Cool. So, top of the fraction, I've got 10. And I've got 15 times 3, which is 45. So I combine those things together, and of course you can do this mentally. You get minus 35. And the surd part, we've got 25 take away 6, which is 19. Bottom of the fraction, hopefully you can see that these parts are going to cancel. Don't worry about them. And then I've got 25 take away 27 on the bottom, which is minus 2. So that is fully rationalized. I've got rid of all the surds. Don't love having a minus 2 on the bottom, but we can do something about that shortly. Let's write these three things out. So that's what I had to start with. I've changed them all. So the 5 root 48 that I had is now a 20 root 3. The crazy rationalized expression is minus 35 plus 19 over 3 over minus 2. And I think we had the last one. I think it was a subtraction. We'll double check. Yeah, it was a subtraction. And that was a 24 3. So that's what I've managed to break it down into. This thing in the middle here, I can still combine that with these other two terms, because I can see that there's a expression with a root 3 in it. I know that I will have to combine everything together. But I've also got this numerical bit. I've got this 35. What I'm thinking is to use a rule of fractions to break this down. I'll keep this as it is. The rule of fractions is to write these two things separately. So split the numerator up. So 2 negatives when divided become positive. So this is going to work out as think 17.5, or you can keep it as 35/2 if you prefer. This is equal to minus 19/2, 9.5 if you prefer. And these three terms, 1, 2, 3, can combine together. So I've got this single numerical bit, which I'm going to leave alone. I've got 20, take away 19/2, take away another 24. It's going to give me minus 27/2. And because they all have root 3 by them, my result here is also going to have a root 3 in it. Let's see what this looks like. So it's going to be 35/2, take away 27 root 3/2. That could be expressed as a single fraction again, if you wanted. And that is that Surds question. Run through the mark scheme for question 1. There are independent marks for working out the first and last terms, 1 mark each. There's a method mark for knowing to multiply by the conjugate, an accuracy mark for the top and the bottom, and the final mark is for tidying up the whole expression, combining all 3 terms together. Okay, question 2, and here is some first principle work. What it's useful to do with any first principle question is just to very quickly verify what the answer is using your shortcut. So the process of differentiation is to multiply by the current power, so 3 times 2 gives me 6, and then subtract 1 from the power, give me a power of 1, which doesn't necessarily have to be written, and 7x would differentiate to 7. So that's what I'm expecting to get. The formula for first principles is as follows. So the limit as h goes to 0. Let's get ready to write our fraction bar of f of x plus h, subtract f of x, all divided by h. Now I think what I'm going to do before I deal with this fraction is I'm just going to write down what f of x is, which is the equation given to me in the question. And I'm also going to work out what f of x plus h is, and I'm going to fully expand it before it goes in that fraction. So working out f of x plus h, replace any x with x plus h. And it's going to look like this. Instead of 3x squared, 3x plus h squared. Instead of 7x, it's going to be 7x plus h. So my first step, as I've already said, is try and expand this, see what I get. Also, little pro tip for you, I'm going to expand these brackets first, then I'm going to multiply it all by 3. I'm not going to worry about the 3 until afterwards. This is a double brackets. It's going to give me following. File it all out, and this is going to give me 7x take away 7h. And if I expand all of this, and I probably could have combined these together first, but it's all good. We can merge them now to get 6hx. Cool. That is f of x plus h. Let's highlight that. So we're going to be using that very soon. And let's also highlight f of x. Zoom out a tiny bit. Both of these things are going to go into this formula. Sub that in there, that in there, and we're going to see how it all comes out. I'm going to write down the formula one more time with the limit on the right hand side of the equals. This time, instead of writing f of x, I'm going to replace it all, well, f of x plus h, sorry. I can replace it with this thing that I've worked out. That is f of x plus h, all here in this big square bracket. Then I'm going to take away the value of f of x, which is just this little thing here, 3x squared minus 7x. It's all of h. Cool. So from here, what generally happens with first principle problems is everything in this bracket is going to cancel out with some of this stuff. And hopefully you can see that the 3x squared terms are going to cancel, and so will the 7x terms. So the signs are both minus, but because this is a minus, it does still cancel. It becomes a plus. The stuff that I'm left with have a look. What stuff have we still got in this brick bracket? We've got 6hx, 3h squared, 7h, all divided by h. Every single term in it now has a h, so I'm going to divide it through. Get rid of one there, one there, one there, with the one there. And I now have 6x plus 3h minus 7. And now I'm going to act on this part of the equation. This allows me to essentially set h to 0. I'm going to replace the h in my equation with a 0. And I get my expression, which is what I was hoping for. Amazing. First principles, there's 5 marks available. There's 1 for having the idea to write x plus h in. There's an accuracy mark for having it completely correct, and a method mark for knowing to subtract one from the other. There's another method mark for fully writing out correctly the formula for first principles and including the limit as you go through. And then there's a final accuracy mark for having 6x minus 7. This is only supposed to be awarded if everything else is correct. Okay, question 3, work on coordinate geometry. I feel like this is always an opportunity to kind of draw a graph to see what can help me out here. I've got 2 points given. One of them is the coordinate 0, 5, which I'm going to put somewhere on the y-axis. I've got another coordinate 3, minus 1, which I guess can go down here somewhere. I'll be coming back to this drawing and adding things in as I learn more, because I'm kind of reading ahead and I can see that there's like 1, 2, 3 different lines that they're telling me about, and I can see that I've definitely got a point C, D, and E that I need to think about. So there's going to be a lot going on later in the question. First part is just to find the equation of the line L1. That's just the line that joins up these 2 points. There we go, that's better, cool. So I'm going to need a gradient first of all, going from A to B. I can see already that the gradient is negative, it's sloping downwards. So I'm hoping that I should get a minus value for my gradient. The gradient formula is the change in the y values divided by change in the x values. y2 take away y1, x2 take away x1. So let's this as y2, this is y1. So it's going to be minus 1 take away 5. And on the denominator, I'm going to do 3 take away 0. So that's going to be minus 6 over 3, which is the same as minus 2, which sounds about right because it looks quite steep. So now I'm going to write down the formula y equals mx plus c. And I know that the gradient of this line is minus 2. I'm going to replace m minus 2. From here, I'm going to replace x and y with a coordinate that's on the line to help me find out what the constant is, the y-intercept. And you could be clever here, and you could say, oh, I already know what the y-intercept is because I know it crosses the axes at 5. So this is why drawing it can sort of jog your memory, can help with things like that. I'll plug in the coordinate at a just to show algebraically. It's going to do the same thing. Let's plug in 0, 5. So there'll be a 5 over here, 0 there. And keep in mind, this sounds obvious, 2 times 0 is 0. Fortunately, I marked at least one paper where 2 times 0 was 2. It's a shame. So the constant comes out as 5 anyway, and we get y equals minus 2x plus 5 as our line. That is part A and 3 marks in the bag. Part B says there's another line, L2. It's perpendicular to L1 and it passes through the origin. So I'm going to just call this L1. So there's another line, let's go green, goes through the origin and it's perpendicular. So there's like a right angle here. Not quite a square, but it doesn't matter. So that is the line L2. This is only 1 mark, so there shouldn't be a lot to do. I know a formula for perpendicular lines. If 2 lines are perpendicular, then their gradients should multiply to make minus 1. I know the gradient of one line already, minus 2. So if I do a little bit of rearranging, work out that the gradient of the other line is 1/2. And you guys might be familiar with a shortcut to change the sign and flip your gradient, and that obviously gives you the same thing. Gradient of this line is 1/2 that in. And apologies, I've automatically subbed in that value of m. I've gone straight there. I also know that it passes through the origin. The origin is the coordinate 0, 0. So if I plug zeros in to both sides, the constant will work out as 0. Therefore, the line is just the line of x. And that is the next part. That is part B sorted. Cool. So progress being made so far. What's going on next? The lines L1 and L2 intersect at the point C. So where they cross, that is the coordinate C. I don't know what it is yet, but I can get a sense of, I know that it's in the first quadrant, so the x and y values should be positive. Calculate the area of the triangle OAC. Oh, okay, cool. So that is the origin. I better label that. And the question's asking me to find the area of this triangle here. So what I'm thinking is, it is a right angle triangle. I could approach it like this, that being the base, and this being the height. I could find the lengths of OC and AC. That would work. I definitely need the coordinate C before I can do that anyway. Another approach is I could say this is the base of the triangle and this is the vertical height. So if I know what the x coordinate is for C, then I'll know this distance. We'll work out the coordinate C first. So that's where the lines cross. So I need to write down both lines. And make sure I write them down correctly because the gradient was -2. The other line was y equals a half x. Now, to work out where two lines cross, I need to solve them simultaneously. I'm going to do simultaneous equations on these two things. I think the easiest way would be to set, because they're both y equals, would be to set these two things equal to each other. I think that's what I'm going to do. So we'll have -2x plus 5 equals a half x. We'll take the 2x over, and we'll have a half x plus 2x, and that's going to be 2.5. And then I can get x by doing 5 over 2.5, which is give me an x value of 2. So I know this coordinate here, C, has an x value of 2. Don't know a y value yet. So I need to plug in 2 into either one of these equations. It doesn't matter which. Chuck it in there. That looks nice and simple. So y equals a half x. I know that x is 2. So my y value is going to work out as half of 2, which is 1. Then I've worked out the value of C. It's 2, 1. Right, awesome. Let's get rid of some of my additional bits of information here. And let's just grab that diagram again, copy and paste it, so I can see it a little bit lower down at the same time as everything else here. So I'm thinking I've got rid of the line. Devastated. Let's put it back. There we go. I know that going from the origin up to A, that the distance is 5 because it's just a vertical straight line, just goes 5 up. And I can also see that going across from the y-axis, I'm going 2 across, therefore this is a change of 2. So using the formula for the area of a triangle, half base times height, and say that it's equal to half 5 2, and the half and the 2 cancel, giving me 5 units squared. Just to say, if you were to work out these two lengths, OC and AC, that will work out, and it's exactly the same thing. You will have to use the length formula to do so. If you did it like this, I won't do the full calculation, but OC works out as √5. AC works out as something. I think it works out as 2√5. And when you put it into the, yeah, that would work. That still gives you an answer of 5 when you. So it does work that way. I feel like that's slightly harder, or at least it's easier to make a mistake using the distance formula that way. What else have we got in this part? Let's have a look. Find the equation of a third line, L3. It's parallel to L1 and it passes through D, which is 4, 2. So there's another coordinate, 4, 2. I guess I'll just put over here somewhere, 4, 2, that's D. And there's another line parallel to the first. So it's kind of doing like this sort of thing. And I need to move it over so it actually passes through the point I indicated. Okay, cool. Let's try and work this out then. So I know that if lines are parallel, then they'll have the same gradient. That's the first bit of the thought process, I suppose. So L1 and L3 are parallel, which means that they have the same gradient. Since the line L1 was y equals minus 2x plus 5, it helps me determine that the gradient of L3 must be minus 2. Cool. So let's start with that. Y equals minus 2x plus c. I also know that it passes through 4, 2. So I'm going to sub in 4, 2, and we'll see what we get. So this needs to be the 4. This needs to be the 2. And let's work out what the c value is. Take the minus 8 over to become a plus 8. And we get that the intercept must be 10. Therefore, we have y equals minus 2x plus 10 as the line. That is part D. And I think in terms of the number of marks now, we've got almost all of them, which is awesome. There's just 1 mark left, and it's 1 mark asking for an area again. So there might be some sort of suspicions, I guess, because the previous error question was 4 marks. This is only 1. It might give away that maybe there's a trick or something that we can do here. We're being asked about the triangle ODE, which I think, to be honest, let's get rid of some of my markings again. ODE is what I get if I extend this line all the way up here, extend this line up. So E is where the line L3 intersects the y-axis, so it's this point up here. I know the line L3 had formula y equals minus 2x plus 10. So I know it cuts the y-axis at 10. That is the coordinate 0, 10 there. Something that I kind of did like intuitively, I suppose, is I put the coordinate D on this line L2. And that's because I know this has got a gradient of a half. 2, 1, 4, 2. Those are in the same ratio as each other. 2 is half of 4, 1 is half of 2. So I knew that it would go on this line. And I'm looking at these 2 shapes. And I'm thinking that these are similar triangles, right? Because they've got the same lines that they're constructed out of. They've got the same angle. This angle here is a right angle. This angle here is a right angle. So I think that this triangle is pretty much the same, except the dimensions I think have all doubled. This was a crossing at 5. This is a crossing at 10. This point is twice as far away as this one. 2, 1, 4, 2. I've gone twice as far. So I'm going to use a bit of a cheeky idea, and you could work this out using the length formula again. But I think the number of marks implies that there's less to do. Ooh, and I need to be careful with this because it's not the area, it's the lengths that are double. What triangle did we work out earlier? OAC. Yeah, OAC. Okay. So they are doubled. So in terms of the area, because the height's doubled and the base is doubled, I think it implies that the area is going to double twice, right? It's going to be 2 times 2. So that's going to be 4 times the area of the previous triangle. So I knew that was 5. Therefore, the overall area of that last one is 20 centimeters squared. That's quite a hard part. It can be done manually, but for the number of marks, there is that implication that there's a trick. I would say not all that last mark's not easy to get, but I would hope that at least these 6 marks are quite straightforward, and then as long as you know to proceed with simultaneous equations, we should be able to get some of those 4 marks as well there. The geometry question, there are 3 marks. 1 mark for knowing the formula for a gradient and having the right method, an accuracy mark for having -2, and another accuracy mark for having -2x plus 5, or any correct arrangement of it. You can see here, if you took the -5 over, it become plus. Part B is just the single 1 marker for a line of this form. The simultaneous problem has a few possible solutions depending on how you work out the area. The part where you find the coordinate C is a method mark for knowing to set them equal to each other, and an accuracy mark for getting the coordinate C correct. The other 2 marks for the problem are for working out the area of the triangle. You can either, as stated earlier on, work out the base and height that way, or you can work out the lengths of OC and AC. Either will work and give you the same answer of 5. The method and an accuracy for both these parts. Part D is a method mark for knowing that the gradient should be the same, and an accuracy mark for the final answer. Part E is 1 independent mark altogether, so is very sort of little in terms of working. Okay, here's question 4. We've got some division and we've got 10 marks, which feels quite a lot. First one is asking about a remainder. So I'm going to do this manually with the division technique. So we have 3x cubed plus 2x squared plus x, take away 1, and we are going to divide it. Oh dear, that is not a straight line. We're going to divide it by x minus 3. So we are going to divide the lead in terms. We're going to do 3x cubed divided by x with 3x squared. I'm going to multiply 3x squared by this and write it underneath. 3x cubed take away 9x squared. And I'm going to subtract this. Be careful here because we've got minus 9 is going to give us plus 11 squared. I'm going to bring this term down and repeat the process. Dividing the lead in terms, 11x squared divided by x is going to give me plus 11x. I'm now going to multiply 11x by x minus 3, and I'm going to write it underneath. 11x squared minus 33x. And then I'm going to subtract these expressions once again. These are going to cancel. And x take away 33, once again, negative, double negative situation. Minus 33 is, oops, another 3, put it back. That's going to give me plus 34x. Bring the minus 1 down and start the process again. 34x divided by the leading term is going to be plus 34. Multiply the plus 34 by this over here and write it underneath. 34x take away 34 times 3, which I think is 102 minus 102. And this last bit's going to give me my remainder. I'm going to subtract minus 1 take away minus 102. It's going to become a plus, and we are going to get 101 left over. So that should be the value of our remainder. Let me make that a 0. Super clear. That's making it worse. 101 is my remainder. Cool. Good. Let's have a look at the next part, because this part Doesn't seem related. Generally, when WJC do A and B, the parts aren't related, and when they do part I and II, that's when they are related. Let's grab that and move it further down. We've got a expression, we've got a polynomial, and we're saying that it is divisible by x plus 2. The implication here is x plus 2 is a factor. Now we could go through the long division all again, but I think we're going to encounter a problem when we divide by a, potentially when we do that. It might be better to use the factor theorem, which says that if we know a factor, then we can plug in its sort of corresponding expression, which is x is minus 2, into the equation f, and we should get 0 out. We do so we're going to plug minus 2 in here, and we should get 0 out. Let's do that. Just going to write the expression first of all, set it equal to 0, and write a bunch of minus 2's into the equation. Let's work out on the left hand side numerically what all this comes to. This is going to work out as negative 16. This is going to work out as, minus 2 squared is 4, times by 3 is 12. This is going to work out as minus 2a, and this is going to work out as 6. And if I combine all the numerical bits, I'm going to get minus 28 plus 6 minus 22 minus 2a is 0. I'll take the 2a term over to the other side, and I'll divide by 2, give me a, and I think that results in a working out as negative 11 for this one. Cool. That seems okay. And then it says something about solving the equation equals 0. Okay, cool. So it's the same equation. I know one answer already. I know that minus 2 is a solution. I know x plus 2 is a factor. I don't need to do the factor checking. I guess I've kind of already done that, right? My starting point is to divide this by x plus 2 with the additional bit of knowledge that this is minus 11. So I can write down the formula and immediately forget it. Okay, let's go back and forth, and this was minus 11x, and the last bit was a plus 6. And I know that it's divisible by x plus 2, I think it was, right? X plus 2. I know that I can divide by x plus 2, and it gives me 0 at the end. So let's just check that through. I'm hoping that I just get a nice quadratic up here that I can factorize a little bit further. So that's the plan. I'm going to wait to see what pops out here. Divide the leading terms again. We are going to get 2x squared. Multiply this by x plus 2 and write it underneath. That times x is going to be 2x cubed. That times that is going to give me 4x squared. Let's subtract. These cancel, and minus 3x squared take away 4x squared is going to give me minus 7x squared. Bring the 11 down and start the process again. Divide the leading terms. This divided by x is going to give me minus 7x. Multiply. And subtract again. And when we do this, we are going to get this minus 7x squared terms cancelling. Minus 11 take away minus 14 is going to give me plus 3. bring the plus 6 down, divide the leading term, and multiply one more time, and we have indeed got 0 at the end. So that's good news. Sort of implies that we've got this correct. So what have we worked out? We've just worked out that this cubic can be split into x plus 2 multiplied by 2x squared. What was it again? 7x. That's what we've just worked out there. I'm hoping that these be split a bit further. So I'm going to put a 2x and an x here. I know there's a plus 3 there and a minus 7 there, so I know that the signs must be the same based on the plus 3, and based on the existence of the minus here, they both have to be negative. And I've just got a 1 and a 3 to place in some order now. So if I had 2 times 3, 1 times 1, yeah, that would give me 6. This would give me 1. Yeah, that's gonna do the trick. Fantastic. So I've got a full factorized expression there. So if this is what function can be broken down into, if I'm solving it equals 0, I've got these 3 brackets equals 0. Then we could say that either this one is 0, means that x is minus 2, or this one is 0, which means that x is a half, or the last one is 0, which means that x would need to be 3. Those are my solutions. That's the question. Cool. Part 4, the long division problem, is broken up into 3 parts, a 3, 3, and a 4. We've got a method mark for any attempt at long division, an accuracy mark for having the correct divisor, and a final mark for the correct remainder. CAO stands for correct answer only. In part B, we have a method mark for having the right idea to plug in minus 2, an accuracy mark for the correct equation with minus 2 subbed in everywhere, and a final answer mark for A is minus 11. Third part of this problem has a bunch of different methods, but the main one that people used was this first one, having the idea to divide and coming up with another quadratic after the division. There's a method mark for getting some sort of quadratic with a leading term 2, an accuracy mark for getting the correct division, accuracy mark for having factorization and at least one other answer that's not minus 2, and a fourth mark for having all 3 correct roots. Okay, question 5. It's been some long questions. Question 3 and 4, they took a while. This one, just a 4 marker, although this topic, discriminant, it's a bit abstract, right? It's a bit weird. So let's have a look at what we're dealing with. We've got a quadratic equation. This quadratic has got some k terms in it. So the thing in front of the x is 2k. Let's write down my values of a and b and c, actually. Things that are in my quadratic. So the thing in front of the x squared is, well, there's nothing written. I guess it's a 1. The thing in front of the x is a 2k. And the final term, the numerical term, is an 8k. Let's write that in as well. And it's asking when this quadratic would have no real roots. So if it has no real roots, then you can expect the discriminant to be negative, less than 0. I'm going to sub everything in that I can. Write the brackets in first of all. So it's going to be a 2k, a 1, and an 8k. And quite a few people did this when I was marking actually. When you square 2k squared, you're going to square them both. So you're going to square 2 is 4 and k squared, and like that. 4 times 1 times 8 is 32. Got something like this. Make it a little bit more manageable to solve, I'm going to divide through by 4. Get the expression k squared take away 8k less than 0. And I'm also going to factorize just to help me see the critical values. So when you're solving a quadratic inequality, whether it's the letter x or the letter k, we need to think about it in terms of where it crosses the axes. If you had a quadratic with k, this is telling you that there would be a crossing at 0, a critical value, and there would be another critical value when k minus 8 is 0, which means k is 8. So the crossings would be at 0 and 8, and the quadratic would do something like this. Not the best, bit wonky, apologies. I'm interested in knowing when this quadratic is negative, right? So the part of the quadratic graph that is underneath the x-axis. You can see that here. This is the section. So if I'm referring to that part of the graph, I'm looking at the points that are to the right of 0, values that are greater than 0, but values that are to the left of 8, less than 8. So the region that I need is I need values of k that are, said it wrong straight away there, values of k that are greater than 0, and I need values to be less than 8. You can express that as a single inequality, values between 0 and 8. And that's going to do it for that one. The discriminant problem has an independent mark for having the discriminant formula b squared minus 4ac with each thing correctly plugged in. There's a method mark for knowing to do discriminant as negative. Even if you made an earlier mistake here, you might still pick up this method mark. There's an independent mark for recognizing that 0 and 8 are important critical values. And then there's a final accuracy mark for realizing the full range of answers for k. Question 6, binomial expansion. We've got 1 take away 3x to the power of 9. So what I'm going to do is I'm going to write this out as my combination, my first term and my last term. And I've got powers of 9, so I'm going to have 9c0, 9c1, 9c2. The first term, I'm just going to have 1 to various powers, and the other bit 3 minus 3x. So you might notice I haven't written any powers in yet. It says to do ascending powers for the first 3 terms. What I'm thinking is I need to have like the term that's numerical, the term that's x, and the term that's x squared. So I want these powers to be starting on 0 and going up. And I want these powers to start at 9 and to go down. So I guess it's all to do with whether the x term is on the left or the right, really. Let's try and simplify these terms. So I'm going to just copy and paste this. That's lazy, isn't it? Oh well. Right. The combinations then. You guys can type these in on your calculator to double check things. The combination button is by the division symbol, shift and that. Anything combination 0 is equal to 1. Anything where 1 is raised to a power is also equal to 1. And anything to the power of 0 is also equal to 1. This term's just going to come out as a 1. Both on the same screen here? Maybe, yes, cool. 9C1, however, that will work out as something. That works out as 9. The powers of 1 still apply here, though. Works out as a 1 again. Minus 3x to the power of 1. Raise something to the power of 1. It's like you did nothing at all. And we are going to multiply these three things to give us the next expression. 9 times minus 3 is minus 27. And these things here, let's have a look. 9C2, 36. 1 to the 7 is still 1. And minus 3x squared is going to give me 9x squared, and it's going to be positive. Multiplying these things together, 36 times 9 is going to give me 324, and it's going to be positive. There we go. And this expression would carry on if we were to work on more terms. However, the first three terms is absolutely fine. So there it is. The binomial problem, 3 independent separate marks. 1 for having the correct x term, 1 for having the correct x squared term, and 1 for having the final correct answer. Once again, correct answer only means that only this should be there to get that third mark. Okay, question 7. This was a big one. The first two parts I would say are reasonably standard, and then these last 2 marks, pretty much no one had these correct. that was true in the real exam as well. But you know, you've got to get used to seeing like these like weird small questions which are very difficult. Let's go through it bit by bit though, because 7 out of the 11 marks are pretty nice. And you know, if you have 7 out of 11 on every question, that's an A overall. So let's work through it. The first part is to work out the center and the radius of the circle. If a circle is written in this format, then we can establish that the center is just these numbers here, A and B, and the radius is the value R there. So we want it to look like this. So to do that, write out the equation. We're going to try and complete the square to get it inside these brackets. I think the first thing I'm going to do is just write it so that the x bits are together, and write it so that the y bits are together as well. So completing the square for this bit, we are going to get half of 4 is 2. Take away that number squared. For the y values, half of minus 6 is minus 3. Oh, sorry, technically this should be minus 2 squared. It'll work out the same. It's not going to be a problem. Okay. So let's evaluate some of these numerical bits. Minus 2 squared works out as 4. and minus 3 squared works out as 9. So I'll take both of those numerical bits over to the right hand side. Give me the following expression. And I believe 3 plus 4 plus 9 should give me 16. Okay, so now that I've got it in this format, I should be able to just sort of match it up and compare, right? So the center of the circle should be at 2, 3. And the radius should be the square root of this number over here, which is going to work out as 4. So that's part A. Let's have a look at part B. This part I feel like should be kind of standard, but quite a few people weren't sure how to approach it. You get given a line and you're told that it's going to cut through the circle at P and Q. So that's essentially saying that there's like, try and draw a little diagram to help us out here. You've got a circle. That's circular enough. And you've got a line and they're going to cut. They're going to intersect, and we're going to call one point P and one point Q, and we need to work out what these coordinates are. So the line is x plus 5, y equals x plus 5. The circle, you can use the completed square version, or you could go back to the start and use this version. It doesn't really matter. But we've got two equations, and we're trying to work out where they cross. This is going to be another instance where we use simultaneous equations. Okay, so any instant where you're trying to work out where a line and a circle, or a line and a curve, or two lines cross, always the same idea, always the same approach, simultaneous. What I'm thinking, because this is written as y equals x plus 5, we can replace the y's in the circle formula with x plus 5s. Both of these are going to go in here, and we'll see what we get. I'm just going to draw some brackets. It looks like that, and I've got rid of y. I've only got x terms left to deal with. This looks like it could be a quadratic, but that's good because I know that I'm supposed to get two answers, so I'm kind of expecting there to be two values down the line. Let's write this out as a file. And 6 times x, 6x, and then minus 6 times 5 is minus 30. Let's file this one out. Okay, right, a few bits going on here. I'm going to underline them as I use them. So we've got all the x squared terms. Let's have a look at the x bits next. So we've got 5 plus another 5, that's 10. Take away 4, that's 6. Take away another 6. Oh, okay, they're all going to cancel. Yeah, plus 10, minus 10. Cool, yeah, they do cancel. Let's have a look at the numerical bits. 25, take away 30 is minus 5. Okay, this is a reasonably nice quadratic. Let's take the 5 over. Give me an 8. Let's divide both sides by 2. Get 4. So now that I've got the equation x squared equals 4, x could be one of two things. It could be plus or minus root 4, which is plus or minus 2. So in terms of my diagram that I made earlier, I know that one of these will be minus 2 and one of these will be plus 2. I'm only putting them this way around because this is further to the left than this one is. So if I had the full axes drawn on, yeah, it would be that way around, I guess. However, I'm not quite finished because I have x values but not y values. So I need to work out the other part of the coordinate. I think the line was y equals x plus 5. Yeah, it was. Cool. So that line, I'm going to plug in minus 2. And I'm going to get 3. And if I had plus 2, I'm going to have 2 plus 5, which is 7. And those are my two coordinates, minus 2, 3, and 2, 7. Let's get them on my diagram here. Minus 2, 3, and 2, 7. There we go. Awesome. And I'm going to grab this if I can. Like, doesn't seem like I can. I want to make some space for the next part. You get it? All right, we got it. Cool. Let's have a look at part C then. So these parts, very few people had these right. They are probably the hardest two questions on the entire paper. So don't feel bad if you couldn't get it. There's plenty of other smaller fish to fry. However, looking at this problem outside of an exam situation, you might think like, actually, maybe it's not too bad. The wording is quite tricky. Point P is on PQ, and AB is perpendicular to PQ in the length of PB. Right, so let's break that down. It says that we've got a coordinate B. This coordinate B is somewhere on this line. Move it. Oops, don't want to destroy it. So this coordinate is somewhere on here. A is the center of the circle. Let's move this text out of the way a little bit. Move it to the outside of the circle. A is the coordinate of the center of the circle, and it said that AB was perpendicular to PB. So that sort of implies that we know the direction of this line, PB. It's going this way. AB needs to be perpendicular. Means that B needs to be somewhere here in order for that to happen. Now, it's not particularly obvious, this. Let's mark the center on as well, which we said the center was 2, 3. Yeah. Okay. Yeah, not obvious, but this coordinate B, in order for this to happen, to have this perpendicular property, it needs to be exactly in the middle between P and Q. I think you can only get that if you've drawn a diagram of this situation, and it is hard to interpret. So working at the midpoint, I need to average the x values, and I need to average the y values. That's going to give me 0 and 5 for this coordinate here. I also need to work up the length of PB. So I'll chuck it into the length formula. I'm going from -2, 3 to 0, 5. So the change of x, -2 to 0, and the change of y, 3 to 5. This is going to work out as -2 squared, which is 4. And this is going to work out as -2 squared, which is 4. Give me a length of √8, which is absolutely fine to leave as it is, or you can call it 2√2. And that's that part. And we've got one final part, which again, I don't think anyone had this in the class that I marked. Show that the area of the smallest segment enclosed by C and L is 4 pi minus 8. Dear me, right, what is going on there? So a segment, first of all, let's get rid of some of the extra lines and things that we don't need. A segment is the area that is enclosed between the curve and the line. It's this area here, which looks like a total nightmare. This area is supposed to be 4 pi minus 8. That's what we're supposed to come out with. It took me a while to spot this, and like you have to draw a diagram in order to see it. The thing that I noticed was the y value was in line with A and P, and similarly the x value is in line with A and Q, which told me that this here should be a quarter of the circle. It should be a right angle triangle produced there. So if you want that area that is shaded in light blue, it's going to be a quarter of the circle minus the area of the triangle APQ. So let's try and make some space for this. And here somewhere. So the area of a circle. Oh, I should say, sorry, area of a circle. Yeah, quarter of a circle. You did say it. So area of a circle is pi r squared. Area of a quarter is going to be just a quarter of it. I also know that the radius is 4, so I'll put a 4 in. And a quarter of 16 is 4 pi, so that seems to be that part of the formula, right? The triangle part, noticing that this is a right angle triangle, the difference between -2 and 2 is 4, so that's the change going across. And the difference between 3 and 7 is also 4. So if I break the triangle down into half base times height, the base is 4 and the height is 4. 4 times 4 is 16, and half of that is 8. So the overall area is going to be 4 pi minus 8. Cool. So quite tough that you have to draw a diagram, and probably a decent sized diagram, not completely to scale, but accurate enough that you'd spot that the points are in line with each other. I think that's really how you can proceed with that question. For the circle problem, we've got 1 mark for having the correct center, a method mark for any correct way of finding the radius, and an accuracy mark for the right radius. Part B, working out where the line and the circle intersect, we've got a method mark for subbing one into the other, an accuracy mark for having this quadratic, an accuracy mark for having the correct x values, and another accuracy mark for having the correct y values. Part C has a few methods, but essentially one is a method mark for finding the midpoint, and then the accuracy mark for finding the correct distance. The final part is also one method and one accuracy, one for recognizing that it's a quarter circle take away a triangle, and one for deriving the correct formula for area. Okay, question 8, out of the woods with that nasty circles question. This one has got some tricky bits, but for the most part should have a bit of a procedure to follow. I will say with the stationary points question, the answers aren't particularly nice, but that's sometimes how it goes. You know, like we can work with it if it's like a surd answer. It's not really a problem. First part says you've got a curve, and when x is 4, the tangent to the curve has gradient -5. Use this information to show that k is 13. So where it says about gradient, what I'm thinking is I need to be able to find a gradient. I need to differentiate this so that I have a formula that I can put a gradient into. I guess the first part of the question is realizing that you need to differentiate it to continue. So differentiating a 6th x cubed is going to be 3/6 x squared. Differentiating kx is going to just be k. 3/6 can be then changed to a half. The gradient being -5, that can go in place for dy dx. And x is 4, and just go place for x. So that's what we're going to do. We're going to sub a few things in. Gradient being -5, x being 4, and we're going to solve this. And we'll take the 8 over, and we get that -13 is minus k, means that k must be equal to 13. That's the first part sorted. And parts B and C, as I mentioned earlier, the numbers aren't going to be great, but the procedure is very much the same as what we've seen many times from stationary points. Didn't mean to move that. Get that right there. So now we're just going to try and find stationary points for this curve with the 13 plugged in. It was a 6th x cubed plus 13x minus 7, I think it was. Oh, sorry, there's a minus in front. Minus. Was there a minus there? There's plus. Getting late, guys. I'm flailing now. So I've already differentiated this once, which is the first thing I would do to start to find stationary points. So at the stationary point, the gradient is 0. So dy dx is equal to 0. So I'll chuck a 0 over there. And I'm going to attempt to solve this. This is a weird quadratic. I'll start by taking the 13 over. And I'll take the 2 up and multiply. And I get that x squared is equal to 26, which means that x is plus or minus the square root of that, which doesn't give particularly nice numbers. It's roughly 5.1, I think, something like that. Yeah, very close to 5.1. Okay, so since I'm trying to find the coordinates of the stationary point. I've got the x parts of both, but I should get the y parts as well. So if I go back and find out what the formula was, it was this here. Just gonna put in 5.1. Maybe I'll keep it exact actually. This is definitely one for the calculator, this. So it's gonna go into 6 to the power of 3, and then that's a sixth of it. Take away 1326 plus 7. Okay, I mean, we could write it like that, I suppose. Maybe I'll get like a decimal like version of it as well. What is this decimally? Minus 37.9. So this coordinate is around about 5.1 minus 37.2. Just because these numbers are kind of gross, we should have that as a bit of a backup. And then we'll do the same, plugging in minus root 26, and we'll see what we get. Minus in here. And also put a minus in the cubic element there. See what we get. And looks quite similar, I suppose. The number doesn't really look that similar. Minus 5.1 and 51 point. We've got some exact values and we've got some decimal values as well. Either is totally fine. So I've got the coordinates. I haven't determined the nature yet though, so that is deciding what we have in terms of maximums and minimums. I think you can probably see intuitively that this y value is lower, so that's probably the minimum, but we should go through the process to check just to be certain. So we're going to differentiate one more time. Let's find out what dy dx was. It was up here. So if I differentiate again, multiply this by 2, 2 times a half is 1. I just get x and the 13 goes. Just that on its own. And I'm going to plug in these various values. So if x is positive root 26, the second derivative will be positive root 26, which is positive. Therefore, that coordinate is a minimum. And if x is minus root 26, the second derivative will be negative. Tells me that the coordinate is a maximum. So I can now confirm these coordinates. The first, the one that happened with positive 5.1 going in, that is a minimum point. And this one is a maximum. Finally, a 2 marker asking us to sketch the graph and label in the stationary points and where it crosses the y-axis. Okay, no problem. Let's draw our axes. 1 arrow, 2 arrows. So I know that there's a minimum at 5.1 minus 37.2, which I'm going to put somewhere here, I guess. 5.1 minus 37.2, and I'll put another coordinate back here somewhere. Maybe I'll move this up a bit. This one can be minus 5.1, 51.2. I know this is a max, so it goes like this. This is a min, so it curves up. And I know that there are no other turning points, so the curve must do something like that and join up in between. I also know that the y-intercept should be 7, just based on the number on its own over there. So, not a great drawing using my stylus here, but something like that for my cubic equation. Maybe I can do it a little bit better freehand and then add the points on afterwards. Maybe we'll try it that way. Move the coordinate very slightly, and we'll call this 7. Cool. Slightly better that time. So yeah, strange numbers, but hopefully the principles seem familiar. Nearly there. The stationary points problem has 3 marks initially, 1 for differentiation, 1 for subbing in x is 4 and dy dx is 5, that's a method, and 1 for correctly evaluating k as 13. The stationary points problem, I had to change the mark scheme because I messed it up. So, process is still the same and the marks are all the same for each different part. It's just the numbers are quite strange here. There's a method mark for knowing that dy dx should be 0, an accuracy mark for getting the correct quadratic, another accuracy mark for getting the approximate points, a method mark for differentiating again, and 2 accuracy marks for correctly determining the minimum and maximum. Finally, the graph, there's a method mark for drawing a positive cubic curve and an accuracy mark for all of the coordinates given. This does have follow through marks. So essentially, if you make a mistake earlier on, you might still get this accuracy mark. Okay, question 9, transformations. Should be a quick one, this. Just knowing what the various transformations do, I suppose. So the first one is the transformation f of x minus 5. And that is a movement or a shift or a translation 5 units to the right. So this entire curve should move rightwards 5 units. It'll look something like this. I'm going to plot it on its own graph. I'm expecting all of these coordinates to add 5 onto their x values and for their y values not to change. So if I draw this out as a separate diagram, I'm going to have a crossing at -1, 7, and then the minimum value should be at 3 minus 7 now. Not great. One more try. It'll do. -1, 0, 7, 0, and 3 minus 7. Second part, f of x minus 2. This one's a little bit trickier to know what to do with. This is a horizontal of transformation. It's not a movement this time. It's going to be a stretch. So everything's going to get twice as far away from the axes. Everything's going to get like pushed outwards, like so. So nothing's going to happen to the y values, but the x values should all double. Oh, wrong pen. Okay, so with that in mind, what do the new coordinates change to? So this coordinate is going to go to 4, 0. This coordinate -6 is going to go to -12. And the coordinate -2, -7 is going to go to -4, -7. We're going to have a stretched out version of the curve, which doesn't go through the coordinates. It's not my best drawing. It's getting late, guys. Hopefully you can forgive me. I'll try one more time. And I'll just move this coordinate to fit through. There we go. So the idea is that it comes outwards just a little bit. For the transformations, there's 3 independent marks. For the first one, which was a shift to the right, we're looking for an upwards shaped quadratic that bottoms out at -7, the x value of the minimum being at 3, and the intersections being at -1 and 7. For the second transformation problem, we're still looking for a quadratic U shape and the minimum being at -7. We're looking for the second mark for the x value to be -4 for the minimum, and we're looking for -12 and 4 to give us the third mark for the intersection. Last question. We are nearly there. This is the last one. A lot of people didn't answer this question, and that could have been an issue with timing, or maybe just like fatigue. This isn't one of the hard questions in the paper, but it was one of the worst answered on average. I think it was just, yeah, probably just people sort of running out of steam, I suppose. It's a tangents question, but it's kind of backwards. You have to work out this crossing over here. You know there's a tangent at C. You know the coordinate of C, 224. And you know the curve. You know the equation of the curve. A little bit strange. So what we'll do, we'll start with the curve, which is 10x 3x squared minus x cubed. The thing to know about a tangent is it has the same gradient as the curve at that point. So if we know how steep the curve is here, we'll also know how steep the tangent line is there, and we'll be able to do some coordinate geometry clever stuff. We need to know how steep the curve is, so we need to differentiate it. And we need to substitute in the x value, which this point is. So we'll substitute in x is 2, and we will get something out. I'm going to rely on the calculator for this one. And it comes out as 10, which tells me that the gradient of the curve and the gradient of the tangent is 10. So now what I can do is I can say I know that the tangent is a straight line, and I know that the gradient of it is 10. The other thing I know about this tangent is it goes through the coordinate 224. So I'm going to sub those numbers in. 24 over here, a 2 here, and I get that the intercept is 4. The intercept is what I'm trying to find. So I know that the y value of it is 4. And by virtue of being on the y-axis, I know that the x value must be 0. There's the paper. Question 10. We've got a method mark for differentiating, a method mark for plugging in 2 to dy dx, an accuracy mark for establishing that the gradient at that point is 10, a method mark for doing some sort of coordinate geometry work, and an accuracy mark for working out the intercept at 4. Hi guys, so hopefully some of that video is useful to you. I'm going to go to bed now. I'm quite tired. It's like 1:15 me recording this. So yeah, hopefully something's being useful in there. And feel free to pop me a message if there's any queries or questions about any part of it. Thanks guys. See you all soon.